Good morning, students. Welcome to this course on mechanical behavior of materials. So this course will be taught by myself. I am Professor Shashank Shekhar from IIT Kanpur, and we will also have another instructor, Professor Sudhanshu Shekhar Singh. So before we begin the contents, let's briefly go through what this course is all about. So let me share the course details that are there available on the course website. So here is the course details that has been given on the SWAYAM or the NPTEL platform. Now, when we say mechanical behavior of materials, you would realize that it is a very, very vast course. We are talking about mechanical characteristics or the mechanical response of materials. And materials is not just one type of material. There are several types of materials. There is metals and alloys, there are ceramics, there are polymers, and then nowadays we also have composites, which is actually a mixture of one of these primary materials. So the overall response or the characteristics that we understand and we relate with the structure of the materials is very different, and it is related to their structure, like I just mentioned. And therefore, this course becomes really vast. And even in the mechanical characteristics, it is the first thing that comes to our mind is tensile behavior, compressive behavior, but mechanical properties are a lot more than that. It is about the tensile and compressive behavior. It is about the fatigue, fracture behavior, failure behavior. Then there is also creep phenomena, and then there are 3-point bending, impact test, and so on and so forth. So there is a wide array of tests and characteristics that needs to be understood. And our aim is to be able to find out the commonality or the fundamental principles that govern this behavior. And this will obviously be different for different classes of materials. So this makes the course very huge. And with this understanding, the overall course has been divided into 2 sections. So this one is the part 1, which is of 12 weeks. And then there will be a follow-up, which will be of 8 weeks. So overall, this is a 20-week course, mechanical behavior of materials. If you were at one of the IITs or in fact any of the engineering institutes, most likely this would be a full-fledged course, meaning a 40-hour course. But since it is a distant learning module or distant learning platform, so all the contents can be very easily compressed into 20 weeks, as you will see. Who are the intended audience? Meaning, are you the right person to take this course? Any undergraduate student or first-year graduate students from the discipline of materials engineering, mechanical engineering, metallurgical engineering, and aerospace engineering would find this course to be very helpful and meaningful, because most of you are dealing with different types of materials, and you would be putting the courses in putting the materials under different kind of loading condition. In fact, I should have also mentioned civil engineering. And whenever you put a material under a different kind of loading condition, then you want to understand how the material will deform, when the material will deform, what kind of shape it can be given. And you would be able to understand and appreciate only after going through the contents of this course. Now, when we are going through this course, we need certain amount of fundamental understanding of certain topics. What are those topics? Something related to nature and properties of materials. So like I said, when we say materials, it is a vast classification of materials itself, which means you have metals and alloys, ceramics, polymers, and composites. Now, what are their characteristics? What are their structure? Those things we will not be able to cover in this particular course. We will be able to cover only their mechanical behavior, mechanical characteristics. But what is the structure? We may briefly recollect or bring back those important concepts, but those details cannot be covered in this course. And hence, it is good if you have gone through a course like Nature and Properties of Materials. Which industries would find this course to be meaningful? Then for that, you must realize that This course would be useful for various type of manufacturing companies, and that is a very large class of industries. Even automobile companies come in that, even aerospace industries come under that. Everywhere you are basically manufacturing some material, so you are applying stresses, which causes deformation, and hence whether the material gets the shape, and how much stresses to apply, what will be the overall final shape, what will be the defects, and why the defects arise. There will be interaction between strain rate, and temperature, which will give the or determine the final properties of the material. And hence, any manufacturing industry would need, or anyone working in these industries would need a understanding of this course. So we have classified this course type as core, and the duration is given as 12 weeks as it is shown over here. Start date is 24th January and it ends on 15th April, and the exam will be held on 23rd April. So the category, it will be useful, like I mentioned, for metallurgy and material science and mining engineering, materials joining, electronic materials. Even people working in electronic materials would see that there are stresses and strain, and because of that, the semiconductor or any of the components may break, and therefore they need a good understanding of the mechanical behavior of the materials. So even electronic materials people would find this course to be meaningful. Materials characterization, and you can also, anyone doing minor in metallurgy would also find it useful. So what are the overall course contents? This is briefly what we have laid out, the contents, and according to the weeks. So we would be dealing with elastic properties of the materials, like elastic constants, what are the atomistic origin, and then we will understand the state of stress in 2D and 3D, transformational stress, principal stresses, and in this context, we will also introduce the idea of Morse circle, which is very useful in understanding stresses, then a stress-strain relation in isotropic and anisotropic materials. Then we will also talk about viscoelasticity, which is a time-dependent elastic properties. And then finally, we move on to the first plastic behavior, which is the tensile characteristics. And as you would see, that tensile characteristics is, when you obtain a tensile characteristics of a material, you would be able to obtain a lot of very important information for the material response. And that is why tensile test is such a widespread and ubiquitous mechanical characterization technique. You will see a UTM almost everywhere where there is some kind of material testing going on. So, but this is not the only plastic deformation behavior. The other tests or other behavior where you need to understand are other tests for plasticity, are compression, torsion, bend testing, hardness, and measurement. But you would see that overall tensile properties are give you some of the most important and fundamental information about the materials. Then we will move on to the yield criteria. When do we say that a material will yield? What is the effective stress? What is the effective strain? Because you can apply deformation in more than one direction. In a simple tensile characteristics, we know that this is the yield stress. Okay, but what about when you are doing the deformation such that the stresses are multidirectional? There is not only normal and compressive stresses, but also shear stresses. Then how do we know when would the material move on from elastic regime to plastic regime, which is called the effective stress? And that will be the yield stress in that multi-dimensional stress condition. So the material shows some plastic behavior. Now, what is the origin of that plastic behavior? For that, we need to, and particularly when we are talking about metals and alloys, we need to understand the concept of dislocations. And when we talk about dislocation, you would see that these happen on a particular plane, which are called slip planes, and the dislocations are associated with Berger vector, and there are certain characteristics of these dislocations. And these dislocations in itself are elastic in nature, and they have stress and strain fields. So the very fundamental element during the plastic deformation, which is dislocation, is in itself guided by elastic properties. Then we will also talk about energy of dislocations, forces on dislocations, line tension, motion of dislocations, Pearl's model, and concept of slip system. Then we will move on to describe the deformation in single crystal. So in single crystal also you will have slips, you will have critical resolved shear stress, and it will give you a very good understanding about when does the plastic deformation begin. And once we have a good understanding of the single crystal, we will move on to the dislocations in about, not directly about the polycrystal, but about particular types of, you can say, crystalline systems. So we will talk about dislocations in FCC. We will look at partial dislocation, stacking fault, and energy. Then we will also look at dislocations in other crystal systems like BCC and HCP. And then we will move on to understand when and how the dislocations get multiplied, what is their source. And once you understand, have a good understanding of dislocation, we will be able to appreciate why we apply some kind of strengthening mechanism. You would know that we apply some kind of rolling for strengthening of steel. We apply aging, age hardness for aluminum alloys, and that gives it a strength. So what are the origin of this? Why do this give it a strength? So we will look at strengthening mechanism, strain hardening, solid solution strengthening. We will also look at precipitation and dispersion strengthening. And then we will also look at grain boundary and pulp pitch relation, meaning when we are talking about grain refinement for strengthening. And we'll also talk about martensitic strengthening. So this is all what we plan to cover in this course. And along with this, as we go along, we will also talk about the mechanical response in not only the metals and alloys, but also in, say, polymers or composites and so on. Now, what are the good books or the references from which we will be covering this? So some of these important books which are you would find present in almost all the institutes are listed here. So books like Mechanical Behavior of Materials by Myers and Chawla, Mechanical Metallurgy by Dieter, Mechanical Behavior of Materials by William Hosford. This is one book that I particularly prefer. This is the book I would mostly refer to when we are going through this course. And when we are talking about dislocations, then this is the particular course that I like to follow. This is the Introduction to Dislocations by Hull and Bacon. Then there are also other books like Deformation Behavior of Fracture Mechanics of Engineering Materials by Hertzberg, Mechanical Behavior of Materials by Courtney. And all these books are very informative and very classic. So you can look at all these books and select which one works best for you. And accordingly, you can follow that book. Whatever ideas and concepts we talk about, you would see that they are present and covered in all of these books. Okay, a little bit about the instructors, which would be myself. This is myself, Professor Shashank Shekhar from IIT Kanpur, and another one is Professor Sudhanshu Shekhar Singh, who is also from IIT Kanpur. So I have been in IIT, it should be 2011, since 2011, and right now I am an associate professor, and I have taught this course in IIT Kanpur for several times, and even Professor Sudhanshu Shekhar Singh has taught this course on mechanical behavior of materials several times. Other than that, I have also taught courses on manufacturing. So my domain is physical mechanical metallurgy, and Professor Sudhanshu Shekhar Singh also works on similar domain, physical mechanical metallurgy. Okay, so now coming to the course certificate. So as long as you want to just learn, so enrollment is completely free thanks to this platform, Swayam by Government of India. This course is free to enroll and learn from. However, if you want a certificate, then you have to pay a nominal fee, which is currently only 1,000 rupees. And exam, you will have to complete an exam, which will be held on 23rd April 2022. In fact, it will be held in 2 sessions. And in order to get a pass certificate, and in fact, there are several levels, elite, gold, platinum, and so on. So in order to get any of this, but the minimum requirement to get a pass certificate is that you have to pass 2 parts, 2 components, the assignments, which will be given out weekly, and exam, which will be held on 23rd April. And the weightage of the assignment is 25%, and the exam weightage is 75%. And you will be evaluated out of the 8 best assignments out of the total. So since there are 12 weeks, so there will be 12 assignments. And your 8 best assignments will be counted towards this 25% weightage. For the 75%, which is exam, that will be conducted at the day of the exam, 23rd April 2022. And your final score will be average score plus exam score. Now, for you to be eligible for a certificate, you have to score 40% in both the components, meaning 40% out of this 25 and 40% out of this 75, which means you must have greater than equal to 10 out of 25 in the assignment and 30 out of 75 in the exam. If you do not meet one of this, and it is very unlikely, if you follow the course regularly, you will be easily able to get 40% in both the assignments as well as in the exam. However, if you are not able to clear even one of these, then you will not be able to get the certificate. So please keep in mind that you must get 40% in the assignment as well as in the exam. And 40% in the assignment means 10 out of 25, and 40% in the exam means 30 out of 75. And the certificate will have your name, photograph, and a score in the final exam with a breakup, and only e-certificates will be given to you. Okay, so this is the overall summary of the course that we will be going through, and I sincerely hope that you get to learn in this course, and there will be a lot of learning in the course in terms of, like I said, the mechanical behavior of materials, and we will be talking about metals, alloys, ceramics, polymers, and composites as we go through. And this, again, to remind you, this is the first part of the course, which is 12 weeks, and then there will be a follow-up course, which will be part 2, which will be an 8-week course, where we will mostly talk about fracture, fatigue, and creep. So with this, we will end this introductory lecture, and when we get back, we'll talk about elastic properties of materials.